All right, welcome everybody to the Daily Space Weather. And we've got some interesting activity. Coronal mass ejections. Coronal mass ejection warning stays in effect. New sunspots. Solar flare warning. And lots more. Check out this coronal mass ejection that kicked off last night, right just after midnight. This is 304 angstroms ionized helium from the Solar Dynamics Observatory. So we're back up to 5 sunspot groups now, as we see activity steadily rising on the closest star, the local yellow dwarf, El Sol. And if you've got comments directly for the sun, please leave them in our comments section. Perhaps we'll read them on a future video. Here's a composite image. This is 1700 angstroms and 94 angstroms, showing you additional detail of that coronal mass ejection and solar flare. It was a C-class solar flare. Also, the formation of this new sunspot down here, a new beta-class sunspot group forming down here at a very high southern latitude. We've got lots more imagery of it. Just spectacular stuff going on just after midnight, early this morning on September 8th. This is another composite, by the way. This is 193 and 304 angstroms ionized iron and helium. And let's blast through more imagery here because we've got lots of stuff to cover. Let's check out the view from Lagrangian point 5, where stereo A is located, to see that coronal mass ejection somewhat in the Earth vicinity. So this is yet another reason why we've had a continuing coronal mass ejection warning. It still has not expired, folks. There is still high likelihood of additional Earth vicinity coronal mass ejections. If you're a new viewer to the channel, please realize that we've been forecasting coronal mass ejections for about 6 months, and only in this area. So we don't forecast them on this side of the sun. We only forecast them in the earthly portion and around the poles, as these are the only likely coronal mass ejections to be geoeffective. They can come from the other side of the sun, but we don't forecast them there to not get inundated with too much information for our viewers, etc. Our viewers, our donors, and so forth. Anyway, there's the view from stereo A. That's the raw data on the left and the difference imagery, the raw data subtracted from previous raw data on the right. And if I had to guess, which I don't think it's Earth directed. I think it will miss to the west. However, there is missing data from the Soho-Lascaux C2 and the C3. So the last frame here showing up just after the coronal mass ejection. We're seeing some ejecta on the right side, the west, and not the left side. We'll probably do an update later today on the trajectory of this. Here's a rock back and forth of the events using the SDO browse data. And you can see that C-class flare erupting from that northern sunspot group. It's quite huge. The umbra is like the size of the Earth. By the way, the sunspots have largely shrunk. So we've got a new sunspot down here, but for the most part, we've seen a reduction in umbral area. Again, that doesn't cause us to turn off the coronal mass ejection warning or the solar flare warning. Still likely to see large flares and additional Earth vicinity coronal mass ejections. Here's a close-up of this rather spectacular event. That's just ionized helium, 304 angstroms from the SDO. Additional compelling imagery later in the video. So the 10.7 centimeter radial flux, the most proportional data set to sunspot number, has come up to 101. So the highest levels of radial flux we've seen since December of 2020, as cycle 25 continues on its ramp up toward solar maximum. Here's the Space Weather Enthusiast dashboard, forecasting no storms at the moment, no geomagnetic unrest, although we did get into geomagnetic unrest recently. And let's take a pause here on space stuff to look at some seismicity. Current seismicity level very high. There's been a 7 magnitude earthquake at Mexico, and also some other large quakes. An uptick in seismicity here. So we saw a 6.0 in Tonga. That was actually early in the day yesterday, just about 24 hours from when we recorded the video here. So Peru saw a deep quake. Tajikistan saw a 4.7. And we're just letting the list scroll here as we don't want to spend too much time on this as there's plenty of space weather to cover. Greece saw a 5.0. There's this 7.0 near Acapulco, Mexico. By the way, the tsunami warning has passed. There's no apparent tsunami generated from this. And I heard it was off the coast. Apparently it is on land, reducing the likelihood of a tsunami there. Anyway, all alerts have been exhausted for that. So a little uptick there in seismicity there with that 7 magnitude quake and the 6 at Tonga. Volcanic activity, we're seeing some additional volcanoes showing up here on the list at volcanodiscovery.com, including some ground deformation on Iceland. I ask ya, did you know about Askja? Yeah, well, it began to inflate in August of this year. And so perhaps a new eruption about to happen in Iceland. Suwanosejima in the Ryukyu Islands producing an 8,000-foot ash plume. Ibu on the Indonesian isle of Halmahera exploding. Flight level 060. It's a 6,000-foot ash plume. Samisa Pochnoi still erupting in an explosive fashion in the Aleutian Islands. 10,000-foot ash plume from it. Also sulfur dioxide emissions. Don't breathe the sulfur dioxide. If you're pole vaulting the caldera, please don't pole vault the caldera. Fuego exploding, producing a 15,000-foot plume of volcanic ash over Guatemala. Revenador exploding as well, 15,000-foot ash plume over Ecuador. Sabancaya exploding, producing a 24,000-foot volcanic ash plume over Peru. And we're not sure if Nevados de Chilean is erupting. Please assume it is, and don't build a campsite at the bottom. And don't go to the top and attempt to pole vault the caldera. Do visit our Redbubble shop. You can find links to that at smAsho merch link at smashomash.com. And throughout the next today and tomorrow, September 8th and September 9th, you can save 20% store-wide. While we encourage our viewers to not pole vault the caldera, we do encourage you to inform your friends and foes about our channel and our merch and support us that way. Lots of products there featuring the design, do not pole vault the caldera. And back to space-based instrumentation on the GOES 16 and GOES 17. Here's the GOES magnetometer data for the past 3 days, and we just saw some recent spikes here, although Earth is solidly in a North Pole current sheet. Let's take a look at the top view ecliptic plane field plot, and you can see Earth in this green area at the moment here. There's the last image. Green in a North Pole orientation there. There's the last image. Green is north, red is south. We expect Earth to remain in a North Pole current sheet for the foreseeable future, up to and including tomorrow's daily space weather video. Here's the line of sight view of the same data, including the solar magnetogram. Nothing too exciting going on there. Here's the line of sight coronal hole plot, which shows you the sun's B field, which is finally starting to show some signs of the progression through cycle 25. A couple of weeks ago, we forecasted an uptick in coronal holes, and indeed we are seeing that come to fruition, as our forecasting on the channel is near 100% accuracy in nearly every aspect of forecast that we do. Next, looking at solar flare probability, and we see very high levels of solar flare probability here. The likelihood greater than not of large solar flares. And you can see that new sunspot group forming down there. It's a new beta class sunspot group, so major likelihood of large flares. Continues. Coronal mass ejection warning continues on. And quick reminder, don't confuse solar flares and coronal mass ejections. Solar flares are X-ray photons. X-ray photons. Coronal mass ejections are primarily hydrogen nuclei, protons, massive particles compared to photons, obviously. Next, looking at the 3 days of X-ray flux here, you see that C-class flare having happened just after midnight. Peak flux showing up here around 0 dark 10 minutes. So 10 minutes after 0 hour there, the peak flux, that C-class flare and associated coronal mass ejection propagating at that time. No spikes in the proton flux, so no relativistic particles have struck the Earth geospace yet, and we're not expecting any to. Again, if I had to guess, I'd say the coronal mass ejection will miss to the west, but we'll have to wait for additional data to make any definitive statements about that. Next, looking at the real-time solar wind, it looks like another coronal hole wind stream just showing up now, as we see the solar wind density dipping from about 25 protons per cubic centimeter, make it 27, now down to more like around 6 protons per cubic centimeter. 5.74 is the current reading, or so. Current solar wind speed, 420. And next we're going to show 2 geospace magnetosphere movies and also ground magnetic perturbation. So next thing we're looking at here is our geospace magnetosphere movie. It's 4 hours of data showing the plasma density in protons per cubic centimeter. Light colors show low density, dark colors show high density. And we should see this subside a little bit here toward the end. Pretty high density showing up there. Next, pressure. We're expecting the pressure to subside too here, although pressure looks quite high. Anyway, it's 4 hours of data just like the last slide. And this is magnetohydrodynamic pressure modeled in nanopascals. The last was protons per cubic centimeter. This is nanopascals magnetohydrodynamic pressure. Pretty high pressure here over the past 4 hours. A little bit of a subsiding there toward the end of the 4 hours. Next, ground magnetic perturbations. And we see some pulses coming out of the South Pacific. Keep in mind we are approaching an equinox, and equinoxes are much more geomagnetically active than solstice periods. And we can see some of that happening now, the past 4 hours here. Geospace delta B changes to Earth's B field. We showed you the sun's, there are changes to the Earth's. And we saw a brief period of geomagnetic unrest here. Just after midnight, KP index went up to geomagnetic unrest conditions, unsettled, KP4. Now down to a KP3, a little more relaxed. And we can expect to see an increase in the solar wind speed here, if I had to guess. See it maybe reach 450 kilometers per second would be my back-of-the-napkin guess. Next, some astrography. Here's where stuff's located. Congratulations on all of you reverse werewolves having a good sleep the past 3 nights. We'll advance this 1 week. There's where things will be in a week on September 15th. Here's a star chart. We've drawn in the ecliptic, which is the yellow line, and the blue line is the galactic plane. And my star chart faces the south. You may see the conspicuous constellation of Orion if you're located in Lehigh Valley. And here's the largest single object visible to the naked eye. It's Betelgeuse. It's a star that's so big that if it were in our solar system, we'd be inside of it. It's like the size of Mars's orbit. Interestingly, similar in size to the even more interesting star, Deneb, which brings us to our cosmology segment. It's going to be brief. We're going to talk about M31. We're not going to pick any random numbers or anything like that. Let's take a look at M31. Here's M31, more commonly known as the Andromeda Galaxy from the Pan-STARRS incredibly detailed optical survey. Here's the Andromeda Galaxy in ultraviolet light from the Galix. Spectacular imagery there of the loosely knit spiral galaxy M31, the Andromeda Galaxy. Here's what it looks like in X-ray. This is a false color image showing 3 different photon voltages. And that's what's going on in the X-ray emissions of M31, giving us insight into what's going on toward the core of the galaxy. which is a very interesting place. So there's M31, the Andromeda Galaxy in X-ray. And here it is in infrared light. That is from the 2MASS infrared survey. And you can even see some aspects of its spiral arms here expressed in infrared light. Heat, the heat being emitted from the Andromeda Galaxy. We're talking about it because of the astronomy picture of the day at apod.nasa.gov. There is the Andromeda Galaxy. This is a Hubble survey here, and the colored portions you see are hydrogen gas. So space isn't empty, folks. Space, it just isn't empty. And if you head to apod.nasa.gov, you can check this out yourself, apod.nasa.gov. Lots of hydrogen out there in interstellar space. And if you hover over this image, it will show you what the objects are. It's the Triangulum galaxy, known as M33, the Meroc, which is just a star in the Milky Way galaxy, and of course, M31, the Andromeda galaxy. Fantastic imagery there of those intergalactic scale objects. And there's Triangulum, another satellite galaxy here. M31 is the largest in the local group, followed by Milky Way, followed by Triangulum. And that's today's Cosmology segment. Make sure you check our other Cosmology segments on our playlists, youtube.com/smashamash/playlists. There's lots of stuff there besides space weather videos. And check our Do One Thing playlist. We actually created another Do One Thing video yesterday. Let us know what one thing you did. Here's another thing we're doing, looking at charging hazards. And we see some charging hazards here over places like Central America and southern Mexico. Some surface charging hazards here could be causing some communication outages. Don't assume it's a cyber attack. It could be because of space weather. Here's a one-year chart of the electron flux as reported by Solon.info, and we're seeing some high levels here in some parts of the planet. Let's get to it. First, the 3-day chart. And you can see not quite reaching to electron warning levels here, although we are expecting electron warning levels based on the available data. So there's your forecast for electron flux. We're expecting additional electron warnings today coming. The forecast model there showing flat levels. I would expect this to be a little bit higher based on the data that I've looked at. Here's a diagram of Earth Van Allen belts. And many of those electrons are located in the inner Van Allen belt. Let's take a look at the total air column here. The electron density all the way from ground level up to a geosynchronous satellite, which would be a GPS satellite. And we're seeing very high levels of electron flux here. You see those dark orange areas, those reddish orange regions, very high levels of electron flux, very high likelihood of massive 1,000+ mile errors in your GPS if you're in those reddish locations there. So expect some communications breakdowns today as a result of space weather. Next, diagram of the ionosphere. It's showing you things like thermospheric temperature, electromagnetic radiation penetration through atmospheric layers, and molecular density in the thermosphere. Here's an ionogram. And we're expecting to see some anomalies here associated with those areas of high electron flux. It would make sense, especially to our viewers who understand the physics. So we're seeing certainly some high frequency anomalies here around northern South America. And I don't want to try to interpret this ionogram too much. I'm just going to show you the anomaly map instead. First, the latest image. That's from 9:45 Universal Time. Things looking normal at that moment. And here's your anomaly map. This is departure in megahertz from the 30-day median. And you can indeed see some high-frequency anomalies here around southern South America. Keep in mind, folks, we've got a South Atlantic anomaly, which is now over the South American continent. Another smaller one down here by South Africa. Two very weak spots in the magnetosphere. And you can see where those are located by these lines here. There's the latest image, 9:45 Universal Time. Things looking normal at that moment. Did you know that the Smash News Network least busted name in news covers meteorology as well as space weather? Well, it's true, folks. There are a lot of videos in our playlists. Check them out. Here come bonus features in the form of the El Teide Spain ground-based solar observatory. To see the latest imagery of the closest star, El Sol. Helios, known by many different names. Anyway, we'll be keeping an eye on this, and when I say eye on, oh, well, the pun is intentional. Here's your latest refresh. The solar intensitygram, and check it out. New beta-class sunspot here at a very high southern latitude. The rest of the sunspots have largely degraded here, but there still is a high likelihood of solar flares and additional coronal mass ejections. Here's your refresh of your magnetogram. And yeah, exciting stuff going on. Exciting stuff. Here's a full disk view in my favorite wavelength, 171 angstroms. Spectacular imagery of transverse waves created during that solar flare / coronal mass ejection event up here in the northwest. We'll let it play through one more time and show you additional views here. Here is a composite. This is 131 and 94 angstroms. And these are the best wavelengths to look closely at coronal mass ejections, folks. They take 10 images per minute instead of only 2 images per minute at these wavelengths, 131 and 94 angstroms from the SDO. And we'll close out things with a close-up here in 193 angstroms. Look for another video coming out today about the trajectory of the coronal mass ejection. Again, if I had to guess, which I don't, I would guess it's going to miss Earth to the west, but it's a little too early to tell at the moment, so we'll just leave it there. Thanks again for tuning in. Don't forget to press like and subscribe if you haven't done so. Share the videos on your social media. We need your assistance to get our channel out there, and thanks to everybody who's been sharing the content. Thanks to everybody who's simply viewed. Congratulations on realizing our channel exists, and may that solar wind be at your back.